Hello. In today's session, I am gonna inspect an article or a question on Stack Overflow, and I will continue my quest to find out how to use a finite state machine inside an entity component system. My goal remains the same, trying to find the best way to work with the finite state machine along in a ECS powered game engine. Just a reminder, this was from the old engine, and I used object-oriented programming. I reached the limits of this engine, and at some point it became very hard to write code. So now I'm studying how to integrate a finite state machine into the entity component system. Let's go with this question. I would like to use a finite state machine to handle entity states in my game. Specifically, for the purpose of this post, I'm going to refer to the player entity. This sounds very familiar to my issue. My player is going to have states such idling, running, jumping, falling, etc., and needs some way to manage these states and transition between them. Exactly my problem. In an OP environment, the simplest solution was to take each state its own class, to make each state in its own class. I mean, this sounds exactly one-on-one with the old implementation, which is exactly like this. So if we go to where should we go? Player. Each state has its own class that deals with that specific class, and it's pre-registered in a manager. Let's go and have a method called handle input. Take the input and determine if a state change should occur. I think he's referring to the fact that he's listening to the keyboard strokes, and depending on the keyboards pressed, he does the actions, the state changes. For example, in the idle state, if either move right or move left occur, the state would change to a new running state. This is easy and makes sense because the behavior of the state should be encapsulated in the state. Yeah, that's how I did it previously. So for example, each state, everything is here, select food. Well, maybe not everything, it's on a higher level. I mean, this only sends emits events. However, everything changes when you use a FCM in an entity component system. States are now no longer objects, because that would go against the flexibility of a component system, but are instead different arrangements of components. The jump state might have components like jump component, airborne movement component, etc., whereas attack state might have components to represent an attack like swing component, damage component, sword component, etc. The idea is by rearranging the components, new states can be created. The system's job is to simply handle these components separately, because the systems don't care about the state, they only care about the individual components. The actual FCM sits in a FCM component held by the entity. Okay, this makes a lot of sense, except for when it comes to handling state transitions. Right now I have an input system that looks for entities that have an input component and an FCM component and attempts to update the state of the FCM based on the current input. Yeah. However, this doesn't work so well. The best way, in my opinion, for the FCM to handle input is to have each state determine how it wants to handle input and how to transition to the new state based on that input. This goes back to OP way of implementing an FCM, going against the design of an ECS where components are simply data bags and systems do all the logic. In an ECS, the idea would be to have a system handle state transitions. But that gets complicated because every FCM might have different conditions to transition between states. It crossed my mind. I mean, my last conclusion was to have a state management system that register all the states for an entity. And then for each state, get the entity and update it. For each entity, the state manager will determine what's the current state and update it. Although I still have my doubts on that. So you can't. Okay, what did you say? This goes back to OP. In an ECS, the idea would be to have a system handle state transition. Okay, but different conditions. Okay, you can't simply state in the input system if the input is to move right, then set the state to running. Well, I mean, you can register that in advance and then let the other systems do their work. That would be specific to the player, but may not hold true for all entities. If one day I decide to make an enemy controllable, the inputs that work for a player wouldn't be the same inputs for an enemy. My question, how can I let my FCM be generic? Nah, this is kind of a convoluted statement here. How can I let my FCM be generic enough and flexible enough in an ECS to allow for various implementations of state transitions without having to do explicit if-else checks in the systems themselves? Am I approaching this completely the wrong way? If so, what's the better solution for implementing an FCM in an entity component system? And we have a comment here. The Ash framework has quite an interesting approach. There is a post where the author writes about it. Okay. I'm actually interested in this. He's also got source code available here. Wait a second. Game development. Blog. Finite state machine. Is this from 2016? Okay, this is the article. Finite state machines with Ash Entity Component System Framework. Finite state machines are one of the staple constructs in game development. During the course of a game, game objects may pass through many states, and managing those states effectively is important. Of course. The difficulty with finite state machines in an entity component system like Ash can be summed up in one sentence. The state pattern doesn't work with an entity system framework. You know what? Give me an example of state pattern in TypeScript. Let me just be clear that I understand. State pattern is a behavior design pattern that allows an object to change its behavior when its internal state changes. This pattern is particularly useful when an object behavior is highly dependent on its state and you want to avoid large conditional statement in a code. Here's an example of state pattern TypeScript. And it gives me the yellow, red, green stuff. So you have the abstract state, green state, yellow state. Exactly what I did in the old engine. Traffic light, transition to, set the state, set context, state, set context. Set context. Okay. What if I refresh this? Does it will give a different example? It's giving me a much more simple example. So this one, wait a second. So on this context, this changes it's the same. It's just three classes that implement the same state class that is actioning on performing actions on a context. In my case, with the old engine, it's multiple classes and their context is the player, right? The actor entity. So it's the same thing. So yeah, he says the state pattern doesn't work with an entity system framework. Entity system frameworks use data-oriented paradigm in which game objects are not self-contained OP objects. Yeah, that's the problem. The problem is that ECS is a composition over inheritance. So you can't use the state pattern or any of its variants on it. All the data is in the components, correct? All the logic is in the systems, correct? This is our law by which I'm working on this game. If your states are few and simple, it is possible to use good old-fashioned switch statement inside the system, with the data for all the states in one or more components that are used by that system, but I wouldn't usually recommend that. When creating Stick Tennis, I was faced with the problem of how to manage states of two main entities in the game, as the two main entities in the game are two players and they go through a number of states. Stick Tennis. Oh wow, this looks very nice, if you ask me. Blackberry. This is something, it's like an old game. Prepare to serve, swing arm to toss the ball, release the ball, swing the racket, hit the ball, and so on. Exactly our problem. Stick tennis is a complex example and I can't show you the source code, so instead I'll use something a little simpler with the source code. An example. Let's consider a guard character in a game. He should have stuck to the original game example. This character patrols a path, keeping watch. If they spot an enemy, they attack him or her. In a traditional object-oriented state machine, we might have a class for each state. Patrol state. This is like we did it. Okay. Public class attack state. Yes. And again, to me, this makes sense. I mean, I understand this. And I'm searching for the alternative. In an entity system architecture, we have to take a slightly different approach. But the core principle of the state design, of the state pattern, to split the state machines across multiple classes, one for each state, can still be applied. To implement the state machine in an entity framework, we will use one system per state. Oh my god. One system per state. Holy crap. Okay. Patrol system. This is the constructor. Patrol node, update node, update node. Move along. Enemy, look for enemies. If enemy, bam bam, attack, bam bam bam. Node entity add attack. What is he calling node? The patrol node. Patrol node. Attack system, another system, attack node, and update node. I think he's using a terminology here. Attack node. Is this like in Roblox when you had parts of the character? I'm not sure. So node, attack node entity, if get health energy there, remove, then restart patrol. The guard will be processed by the patrol system if he has a patrol component. I see. And he will be processed by the attack system if he has an attack component. But removing these components from the guard, removing these components from the guard, we change his state. The components and nodes look like this. Patrol, attack, position, health, oh, I understand now. I understand now. So node is still a component. So instead of iterating on entities, he's iterating on components. But actually he's iterating on entities but then extracts the components. Like I'm doing with the query. So going back to my demo. So I guess I'm gonna have a lot of queries like this. Crap. Sounds very scary. Another example. Here's another more complex example using the asteroids game example. That I use to illustrate how Ash works. I've added an additional state to the spaceship for when it's shot, rather than simply removing the spaceship when it is shot. I show a short animation of it breaking up. While doing this, the user won't be able to move it, and the spaceship won't react to collisions with other objects. The two states require the following. When a ship is alive, it looks like a spaceship, the user can move it, the user can fire a gun, it collides with asteroids. When ship is dead, it looks like bits of spaceship floating in space. The user cannot move it, the user cannot fire its gun, it doesn't collide with asteroids. After a fixed time, it is removed from the game. This is what I'm interested in. The relevant piece of code where the spaceship dies is in the collision system. Without the second state, it will look like this. Spaceship head, spaceship next, for spaceship, okay, for each spaceship, asteroid, for each asteroid, if they intersect, creator, destroy entity, spaceship entity, break. The code tests whether the ship is colliding with an asteroid, or if it is, it removes the ship. Elsewhere, the game manager system handles the situation where there is no spaceship and creates another one. If any are left, or ends the game. Instead of destroying the spaceship, we need to change its state. So let's try this. We can prevent the user controlling the spaceship by simply removing the motion controls and gun controls components. We might as well remove motion and gun components while we're at it, since they are no use without the controls. So we replace the code above with okay, next we need to change how the ship looks and remove the collision. Behavior. And finally, we need to ensure the spaceship is removed after a short period of time. To do this, we'll need a new system and component like this. Death throws, countdown, death throws. Okay. So in the death row system, if no death countdown, okay, decrements the countdown, bam. We add the death throws system to the game at the start, so it will handle the drawn out death of any entity. So we added to the game at the start, so it will handle the drawn out death of an entity. Then we add the death throws component. Okay, and that is our state transition. The transition is achieved by altering which components the entity has. The state is encapsulated in its components. This is a general rule of the entity system architecture. The state of an entity is encapsulated in its components. If you want to change how an entity is processed, you should change its components. Then we'll alter which system operates on it, and that changes how the entity is processed. Okay, this makes sense. I need to go up. Attack system, patrol system. So prior to implementing this, you had states like I have, and then you had systems. Wow, okay, I got it. Holy crap, this is powerful actually. I'm trying to not think of performance. The state is incapable. Okay, a standardized state machine code. To help with state machines, I've added some standard state machine classes to Ash. These classes help you manage states by defining states based on the component they contain, and then changing state simply by specifying the new state you want. A finite state machine is an instance of the entity state machine class. You pass it a reference to the entity and it will manage when constructing it. You will usually store the state machine in a component on the entity so it can be recovered from within any system that is operating on the entity. This is a state machine for an entity. The state machine manages a set of states, each of which has a set of component providers. When the state machine changes the state, it removes components associated with the previous state and adds components associated with the new state. Hello. Entity state machine. Okay, states are dictionary. Coherent state is an entity state. You have the entity. You add the states here, or you change the state. Okay. Okay, I understand this. A state machine is configured with states, and the state can be changed by calling the state machine's change state method. States are identified by a string, which is a sign when the state is created and used to identify the state when calling the change state method. Yes, that makes sense. By the way, let me paste this in the chat. This is what I'm reading. States are instances of entity state. They, by the way, how does this look? Entity states represent the state of an entity state machine. The state contains any number of component providers, which are used to add components to the entity when the state is entered. Okay, so I got it. So a state can bring more components, like attach component. Greetings from Bucharest. State, okay. Create state patrol, create state attack. A state is a set of components that should be added to the entity when the state is entered and removed when the state is exited. Oh, this is the most important part. Unless they are also required in the next state. The add method of the entity state specifies the type of component required for the state that is followed by a rule specifying how to create that component. Well, 4 standard rules for components are entity state. Okay. The 4 standard rules for components are entity state add type class. Without the rule, the state machine will create a new instance of the given type to provide a component every time the state is entered. Okay. Other type should be the same as extended with a specific component type. You only need this rule if you create component classes that extend other component classes and should be treated as a base class by the engine, which is rare. I'm guessing he's referring to the fact that you don't necessarily want long-term to create new instances. So you don't allocate the memory every time, but I don't care about that right now. We will create a single instance and use that single instance every time the state is entered. Okay, I understand this. Yeah, he wants to optimize some stuff here. But with singleton, okay. Finally, you can use custom code to provide a component by implementing a component provider. Yeah. Yeah. So yeah, exactly. He's saying that you should have a I should have a component registry, which I already have. So I'm already registering. Well, I'm registering them, but the instances. He's actually saying that when you add a component to an entity, you should cache the instance so that you can recycle it later, something like that, or maybe a pool. I also have this this concept of pool, which is a pool manager. I think I named it object pool, which unfortunately I used objects, but it should have been a map here, I think, or a set. Yeah, so you're adding here the instances, and then you just extract them from here. But I don't care about this. These are optimizations right now. I'm not at that stage. This is used to avoid replacing component. Okay. Back to examples. If we apply these new tools to the spaceship example, the states are set when the spaceship entity is created as follows. Entity state machine spaceship. Create state. Playing. Add motion. With instance. New motion. Add motion control. With motion controls. Add gun. Add gun controls. Add collision. And display. Create state destroyed. Add death throws with instance. Okay. Add display with instance new display station death view. I get it. So he's registering these states that already have these predefined components. Okay, and the state change is simplified to FCM spaceship. Wait a second, spaceship. Okay, spaceship FCM change that state. Okay, this was a revealing article, and we are just at the first comment here. I'm bumping up against a similar question. I need a FCM to manage my player state and then navigate into and out of different menus and modes. I think my approach will be pretty simple as it serves my needs. An FCM component that defines the states and transitions, and any interested system will just examine it to determine if it should do anything. Much of the time the system will look at it and then do nothing. Wasteful maybe, but simple and good enough for me. Yeah, that's my problem as well, but I'm trying to ignore this at the moment. For now, I'd be really curious what you came up with. Swapping components on off is too heavyweight for my needs. It's kind of heavyweight. It depends on the implementation. It's clear that I have to. In my case, it's not heavyweight because my components are actually just some bytes added to a bit mask, bits added to a bit mask. So I don't worry about that. Let me see here. So add component, get component. I will also need a remove component. Which I totally forgot to implement, but there's no problem. So instead of adding that bit of the component, I'm just removing it. But here's the deal. I will not remove it from the component here. This stays. And by the way, this should be a map again. Let's see. So what am I doing here? Am I adding the here is my caching. So this should be like a cache instance, component instance, component instances, right? Or not? Yes, component instances. And then remove component is just taking off a bit mask. It remove from a bit from the bit mask, but it doesn't remove it from the cache. Third comment, infinitely. I never ended up pulling out the FCM code, but here is my project. The state machine code is under FCM package. To see how it's used, there are a lot of good examples. Entity factory, all entities in our game are built there. For more depth information, expansion how it works, I'll be happy to talk about it. Okay, let's see the answer now. Just riffing off the OP's post and his subsequent comments, Ash actually has two FCMs that operate at different levels. First, there is the FCM operating at the entity level that manages entity states transitions. By changing the composition of components on an entity as you transition from one state to another. Secondly, there is a FCM operating at the engine level that manages engine state transitions by changing the composition of systems executed. So it doesn't waste computer cycles just to, go to system A, go to system B, unless you have entities that are going to be executed by those systems. Combined, they make for a pretty robust FCM. The trick is to determine what type of transition you need to work with. One where data composition drives transitions, yes, or one where logic composition drives transitions. I think the first. We want the first. So armed with this newfound knowledge, let's reason about how this would work. In more naive approaches, the changing component to changing components composition, we'd use a number of tag components, yes, along with some lengthy switch statements, if-else checks to handle these changes of entity state, ultimately resulting in bloated systems that do way more than they should. Ash's entity FCM refines this and avoids those lengthy switch statements or if-else clauses by mapping a given component configuration to an identifier and providing a manager that can be used to trigger state transitions. This manager instance can be passed around as a property within a component, or it can be compose injected as a member of a system. I think I like this one better. Alternatively, taking the engine FCM approach, we break out each bit of state specific logic into their own systems. Yes, which I think I'm about to do this, and swap them in out based on the given engine state. This method is nor without its drawbacks, since the absence of a system will affect all entities associated with it. Yes. However, it's not uncommon to have systems dedicated to a single entity instance, for example, a player character, so this can prove useful in the right context. Come to think of it, affecting entities globally via system swaps may be desirable in some cases as well. So what he's saying is that having system executing in the loop, for example, if you would have here a player walking or just walking system. If you don't have entities walking, let's say a attacking system. If you don't have entities attacking, or if you don't have entities walking, these will be wasted. It's gonna be wasted code. Although it's not gonna be really wasted code because the query is cached, and if you don't have any data set over which to execute the query, I think the compiler will auto optimize this. Note, if the scope of your logic modification needs to be more narrow, you can restrict it to the system without involving the engine FCM. This can be achieved by implementing a state pattern within a system where the system can change its behavior by delegating to a different subsystem based on state. No, I want to delegate system through component modification, adding or removing. I've seen some ECS framework label system composition as phases, but they fundamentally act as FCMs, where the ECS engine processes entities using different sets of systems associated with the given phase. Well, what? Where the ECS engine processes entities using different sets of systems associated with a given phase. In closing, data composition is just one half of the equation. How you compose your bits or blocks of logic is just as important when trying to implement ECS, FCM with an ECS. Okay. Let's see this answer as well. The Ash framework has quite an interesting approach. The author writes it here. I read already that article. He takes a similar approach to the one you were suggesting, arguing that an entity's state is dependent on the components that make it up, yes, which in turn determine the system process the entity. What systems process the entity. To make managing the state transitions easier, he introduces a finite state machine class which tracks what components are required for an entity to be in various states. Which tracks what components are required for an entity to be in various states. Correct. For example, an enemy AI may be in patrol state if it has transform and patrol component, so he would register that information with the finite state machine. FCM, okay, create state, bam, yes. When the finite state machine is told to change the state of an entity, it removes and adds components to get the desired state, yes. Any system that needs to change the state of an entity just needs a reference to the finite state machine, something like FCM change. Yes. So basically inject the FCM into the system. He's also released the source code for it that you can find here. And there's a practical example of asteroids, which we are going to look at. The code is in ActionScript, I think, but we might be able to decipher it. And somebody responds that doesn't work well. Let me explain. What if you decide you want the player to run when the inputs for the move left and move right are used? Then you could pull the input and change the state based on these values. Now you decide you want to have a state where the player is frozen and can't move. All of a sudden your FCM breaks. Because now you can run in a state that you're not supposed to run. Transitions are state specific. and shouldn't be defined in the scope of a system. But wait a second. If you transition, so now you decide you want to have a state where the player is frozen. If the player is frozen, then it probably will have a new component is frozen, which is like a tag, and then the running will not move because of that. In that case, wouldn't the run component be removed, which would stop the entity being processed by run system, essentially freezing it? I'm just looking into this problem myself. I've started developing. I've created a much more robust system that allows you to define transition. Then I have transition systems. So if the player is frozen, you have to broadcast that in order to update the query of every system. So you have these queries here, for example, this all entities to render to screen. Let's say you don't want to render an entity, but you're somewhere here in the loop. You will, I don't know, issue a, let's say you're going to change one of the entities. You're going to remove renderable, but in the same time you will issue a remove. So there is a candidate and a remove. So when you candidate something, an entity, for a query, you have to say, hey, this entity might interest you. What should I show here? Yeah, but anyway, would you mind sharing your implementation to see? The code is too complicated to post here, blah blah blah. You can throw it on GitHub. Okay, I think this post alone from more than 7 years ago finally clarified what needs to happen in the code. It's not this. It's not this. It's more along these lines. So I'll write it here. So you have the loop. And you have move system, which you update. You have move render system, which I think should be the last. Okay. Attack system update. Idle system. Okay, and your components and your entities are like this. Const. Let's say player is like a create entity, but then player has these components on it. Let's presume that it's like this. Has keyboard, is idle, and then wait a second, no, it's idle state, attack state, and so on. And then you have another entity. These are components, like a dinosaur. And the dinosaur you have, it doesn't have a keyboard. It has an idle state, it has an attack attack state, but it's also scanning for player. Is scanning for player. And then the player is moving. So move system decides add is moving. Attack system actually this should have been input system, and this decides add is moving and is attacking. So then you have move system and attack system, which will be activated by this. But when you do this, you also, so you add these components to player entity, broadcast to all queries, candidacy to all queries, because you need to inform all the queries in the system that you just added 2 more bits in the bit mask of the component bit mask of the player. So then when you did this, you broadcast it, then the move system will work. So this will work on the next, not on the next frame, but will work instantly. Attack system will work. Idle system will not work because it will not find any entity with is idle. Will not work, and the render system will render everybody because these are renderable. Maybe I'll change this to something else. So then you have 1, 2, 3, 4, 5 loops, out of which only 4 will be executed. Then on the next frame, let's say that you no longer you're no longer pressing anything. So then how do I know, how do I tell the how do I tell the player system? By the way, I need a player system here, especially for the player. Actually, this is a player move system. It's different because it comes from the input. That's why. Hi, welcome back. And my problem is I don't know how to signal that the input system is no longer pressing any keys. So if it's not pressing any keys, it should deactivate this system. So it will be like this. If input system is true, then player can move. Otherwise, there's no reason to perform any updates here. But then I might ask, if there's no update from the input, then how do I notify the render system that it should start the is idle state? So how do I add this tag is idle? There's a solution like this. Player system move, which is like player add component is idle. But it's kind of weird to execute this on each frame, although it will be fast because I have this bit mask going on. And by the way, I need to change my implementation, but it's kind of weird on each frame to add the component is idle, because its is idle component is already there. So it's more like is idle tag, is more like a tag, is moving tag. Because if it has this tag, you know that he's idling. And then the idle system can still execute for the other entities. What up, guys? I think I finally figured out some of the issues that I had last time. But yeah, let me show you something funny here. So there is a new dinosaur in a game that I'm playing. I don't know if you know about this game, but I really like it. So if you are passionate about dinosaurs and you like multiplayer, maybe you will give it a try. Where is it? Where is it? Path of Titans. Where the heck is this? Path of Titans news. It's called Akilobator. So if you never played Path of Titans, I highly recommend it to you to check some videos of this, because it's a nice multiplayer game. Then you can play in a team or solo. Just relax. I love it. Okay, back to the topic at hand. So the question is, how do you know state finished and then other state needs to take over? AYM, you only know English or Turkish? I think that's enough. That's good. So this article as well. Yeah, I know. But I was saying that that's cool that you know English, and I guess you're Turkish, right? Oh. Let's check this game out. So, asteroids. No dependencies. What is this? Input. Key poll. Here is polling the keyboards. Ba 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 ba. Add event listener. Yeah, I have the same. Event activate. He's doing some bit shifting here. Yeah, to my shame, I found out that, so from a fellow colleague from Ukraine, I found out that Ukrainian is pretty different than Russian language. And since I have my grandfather was born in Ukraine, in Donbass, I think. He told me some stories. I think Russians have had some interventions in Ukraine back in the days where when they changed the names. So the first name, the last name. So they changed the terminology so they sound more Russian. So yeah. Ocean game state. Yeah, he told me about, so it's Transnistria. Where is Transnistria? Oh my god. I don't know why I get this on Google Maps. Okay. Never mind. Stay away from Google Maps. So Donbass, I'm not sure if at that time in Donbass there were separatists, but there were there was a heavy Russian influence, and they tried to change the language, change the names, everything with a terminology in, of, everything that ends with an of instead of the actual name. So they give it a Russian connotation and so on. Position, spaceship. So these are the components, which are pretty simple, like they should be. But what about this guy is using the terminology of nodes? What is a bullet collision node? So this is like a composition of components. This is like a collection, like a group of components. What is an audio node? It's just audio. Aha. So nodes are a group of yeah, I think it's I think that was like Russian for UT. What is UT? Slava Sam. UT. Anyway, okay, systems. God damn it, I forgot what I was doing. Movement system. The movement system has a game config and then update node. Ah, okay, so each system works with a node. But still, how does this guy transition from a state to another? Where's the game loop here? Is it in the main? New asteroids. It's asteroids. Engine tick provider. Okay, engine. Entity creator, keep all. Config. Aha. Adds the engines. As the system, sorry. What is the render system? Uh-huh. Okay. But for the move system, what's interesting is that he's updating just a node. He's not updating all entities. Wow. Ukraine. Okay. But is this like an emote? I think it was an emote, right? This what you put here, Slava Sam. It was like an emote after POC. Or was it not? Emoji. I don't know. Romanian English. R after deck. You made me curious. So how is he operating this only on one entity instead, or on one node instead of multiple entities? Because he has a prepare engine, and then when it start, engine. Okay, where is the engine? Engine is in the ash core. System priorities, and he has this system priorities stuff that he's using. Okay, so he's having some sort of priority for he's giving priority to the systems for the order in which they will be executed. Okay. When you wrote, what does mean? This looks very simple, but yet very interesting and complex. So I need to go back to the drawing board a little bit. I need to go in my ECS system, and in the entity I need to change this implementation. But where is he adding a player here? Creator, create game. Is the entity creator. Let's see. Entity creator. Destroy entity, create game. Create, wait for click, create asteroid. Okay, that means that's how it appears to me in my chat. It's probably, I don't know, an artifact or something from the copy paste. I was just curious if it's an emoji or something like that. Create spaceship, and add entity add. So he's creating a state. Where's the entity state machine? This is in the core. Yeah, I saw it too, but it's probably because the client that I'm using, it's not supporting maybe some emojis, or maybe it's just an artifact from copy paste. It could be like some UTF characters. Okay, so this is like a factory. And he has some prefab stuff here. Even the game is an entity. Oh my god, that's brilliant. Even the game is an entity. Holy shit, man. Yeah, I should definitely check the implementation. Fortunately, I'm too tired right now to look at this, but I need to see how he runs the loop. Identity. Component added. Family component add to family. Okay, so I'm close. I think I feel like I'm very close. Component added. Wait a second. Family. It's an interface. I want to see an implementation for family. Var family in families. But who is families here? Family is just a dictionary? The heck? Okay. So my goals should be goals after 31/01/2024. Rewrite entity so it supports register component instance and add remove component on the fly. Cache of component instance. Then Then what should be the next step? Yeah, it's hard. It's hard. I mean, look, I wrote this game. I wrote a lot of gameplays, like with the previous engine. I had it like a strategy one, like a simple one, like a more complex one. I tried all kinds of gameplays. Problem is that the code base was getting so big and it was not easily manageable. So, but you can always choose an engine, right? You can use Unity. I don't want to use Unity or Unreal Engine. It's because I'm a programmer and I need to learn these things. I need to learn them. I need to learn how to do this. Because once you learn this, you can do them in any shape or form that you want. And it gives you a lot of freedom. So you will have a lot of freedom to do whatever you want. Let me see if I can find my account here. I used to have an account here. Oh, okay. And show you, because I used to post. Here's a glimpse. Just a second, let it load. Like this was on my TV and I could actually play the game with the two players. And that guy was chilling here. And I did all sorts of tests, like with the fog of war, like, you know, like in StarCraft, when you walk on the map. Teleporting, all sorts of stuff. I mean, you can do whatever you like if you create, if you know what you are doing. That's the first rule. You have to know what you're doing. And then if you say you don't want to waste time like me on a game engine, just go and use something that's already been made and you just create your artwork and you can do whatever you want. I just enjoy this process. I enjoy it very much. I actually want to do this full time, but right now I have a daily job, so that's why I'm kind of tired. Yeah. So this is it for today. We read the article, we read the question, and I think it's clear what I have to do. Rewrite this entity, and then wait a second, then create tag components. Create tag components, and then just start decoupling and see if this works, if this logic like in here works, because I still don't know what will happen. Attack system will remove the is attacking from the component and will broadcast to all the queries that thing. What I don't like about broadcast broadcasting is that, let's see, you can announce it only on certain queries, I guess. This is something that I didn't program. But anyway, it's getting late. I'm tired. I think I achieved the goal today. Thank you for staying here, and see you tomorrow.